It wasn't me.
All right. So let's discuss through mechatronics. So today we're going to be going through mechatronics, what it is and what the sort of paradigms are. We're going to be talking about the Arduino pins, so like different things that you can do with an Arduino and the sort of structure of an Arduino, which you have in front of you. Then we'll be talking a little bit about digital versus analog, so just the ways of thinking for mechatronics. Then we're going to skip some of the programming components, but then we're going to go straight to the Arduino functions. So there are 6 functions that you need to be aware of, that you need to be really familiar with. And then we're going to jump straight into the exercises. All right, so mechatronics. And before I start, there is a chance that we might have to do a bit of a compressed lunch just because this morning took a bit longer than expected. And we might go a little bit longer at the end of the day, but we'll see. All right, so mechatronics. So mechatronics is a combination of mechanical engineering, electrical engineering, and computer science. And when you combine these 3 together, what you get are smart products. Okay, so products that can interact with the environment and in response to something in the environment actually do something. Does that make sense? So it's sort of like an input-output mechanism. And it's also known as embedded programming. Okay, so it's sort of something that's vastly sort of used everywhere in any medical device because there's usually an interaction with the real world in some way, right? There has to be some sort of input and the device releases some sort of output, okay? So mechatronics itself lies on the sort of spectrum, right? So at the far end on the left there is what's called a microcontroller. So we're going to be using a microcontroller. If you take a look at your Arduinos, there's actually a microcontroller just placed on the Arduino board, okay? And then on the middle is what's called a microprocessor, which is a processor that's slightly stronger. It's more like a computer architecture, right? But it's still, so you'll see this sort of architecture in what's called a Raspberry Pi. So it's a very popular sort of mini computer that you can use, but they're fundamentally different. And then on the far end here is computers, which is called processors, right? So these use sort of very high-end, high-powerful, very large computers that can allow you to do a lot of different things. Now, 2 very popular sort of things in this space is one, the Arduino, which popularizes microcontrollers. So it provides a very easy platform for microcontrollers, which we're going to be using. And then for microprocessors, the most popular platform is Raspberry Pi. Okay, so again, these are very different platforms. And how they're different is that microprocessors, so Raspberry Pi, has this structure here, which is what's called a von Neumann computer architecture, where you have a CPU memory, which is separate, and then they interact, and then you have all these peripherals here, right? On a microcontroller, you simply have the different components just sort of placed differently together. Does that make sense? So it's a very sort of different structure. So this is a computer, and this is what you need for sort of smaller devices that are a lot faster. Now, mechatronics is extremely fast. So one of the sort of main advantages is you're operating now on the sort of millisecond or microsecond scale. So that's one of the sort of advantages, which is you have this very small, sort of low footprint, low cost, low power device. And it's very powerful for certain circumstances, right? So for example, if you're building a car, you want a mechatronics sort of enabled thing at every corner, right? Well, if you have a computer, you only have one for the whole car. Does that make sense? So it's sort of a different paradigm. Now, it does allow computing on the edge or handheld devices because these require such low voltages that you can have just simply a handheld device that does a lot of things, okay? And mechatronics is enough compute for the majority of medical devices, okay? So it's actually everywhere for medical devices. So it's vastly, vastly used. And then you have the sort of next step up, which is called bare metal computing. And this is when you have something like Raspberry Pi. Now, how this differs to standard computers is that there's no operating system. Okay, so there's no Windows, there's no Mac, nothing, right? It's just merely a computer that does things and then you tell it to do things. Now, this leads to sort of moderate speeds, so on the order of seconds instead of milliseconds or microseconds, right? And it has moderate cost, footprint, and power, but obviously it's much more powerful, okay? And then the sort of biggest paradigm is cloud computing, which is required for very compute-heavy tasks. So, for example, AI, generation of designs, that sort of thing, right? And so these usually communicate with edge devices like the ones that we're using. So we won't really tap into it, but these devices can communicate to Wi-Fi, to Bluetooth, all sorts of communication protocols. And this is very powerful for sort of systems and cloud computing. So when you need a lot more compute. Now, you'll see 2 types of microcontrollers. The first is the one that we're going to be using, / is already on your board, right? And so this is called a dual inline package, which means that it has these pins that you can put onto a breadboard, right? In this case, the Arduino has already sorted it out for you. But at the same time, there's another one called surface mounted. which is attached onto what's called a printed circuit board. So if you've ever seen any of these green things here, or even blue for ours, it's what's called a printed circuit board. Okay, so it sort of prints all the components on. Now, it's not like printing like 3D printing, but it sort of just places the components on this board, okay? And then it sort of creates these electrical components, so these routing lines here. All right, now this is a breadboard, okay? So you have to become a little bit familiar with how breadboards work. So how they work is that there is a continuous line along the edges there, okay? So it's sort of longitudinal, if that makes sense. So it runs all the way from the end of the board to the other end, okay? And that's true for this plus and this minus. Okay, and what the plus and minus usually mean is that the plus is 5 volts or like high, right? And then the negative is usually ground. Okay, so please don't sort of screw that up, because when we're trying to debug your circuits, if you flip 5 volts and 0 volts, it's going to lead to really nasty behavior. We're not quite sure what's happening, right? And so you do want to make sure that 5 volts is always attached to this plus and 0 volts is always attached to this. Now in this middle section here, these connections here are all, like these lines here are all connected. Does that make sense? So for example, if you put 2 components here, then that is as if those 2 components are connected. Okay, so just keep in mind that this is connected that way and this is connected this way. And it's true for these 2 as well. Okay, so that's how a breadboard works. Now, the biggest thing that we obviously fear in mechatronics is what's called a short circuit. And so you might have seen this if you've ever done any electrical engineering, but a short circuit occurs when you have, for example, 5 volts here, and there is just a single line from 5 volts to 0 volts. And what happens is that electricity just keeps on running rapidly, and then it basically starts a fire. Okay, so you just have to be something careful. I obviously don't want to start a fire in this room, right? But there is a possibility, if you connect 5 volts to 0 volts, that you will cause what's called a short circuit, right? And could cause like great harm to the people around you or yourself as well. So the golden rule is to never have a line from 5 volts to 0 volts without a resistor, okay? So I'll just talk about what that actually means. If someone can give me a breadboard. So never connect the red to blue directly without a resistor. Does that make sense? Okay, so that's going to cause a fire, so we just have to be careful. All right, now some notes on electrical safety. Does anyone know why these birds aren't killed despite the very high voltages on the lines? Yeah.
Put the feet on.
Sorry?
Isn't like the fact that they
Yes.
just use it.
So essentially what's happening here is that voltage is always a potential, right? So for example, if I just touch 5 volts here, there is no issue whatsoever. Does that make sense? So same with these birds, if they're touching 240 volts in Australia, there are no issues, right? But if they ever complete the circuit between 5 volts and 0 volts, then there will be a short circuit and they're going to die. Does that make sense? So just something to keep in mind. If these birds, for example, somehow they can't, but if they somehow touch this line and the ground, then they will die, right? And so some birds have been caught in a scenario where they, for example, have their wings out like that, right? And they manage to touch both, and that completes the circuit, and they're going to be burnt to a crisp within like a few milliseconds, right? Okay, so again, short circuits, never connect or never have a line, even if you have like a different component here, right? Like these 2 connecting and these 2 connecting, right? You should never connect these without a resistor. Does that make sense? And make sure that in your circuits, you never have 5 volts leading to 0 volts without a resistor. All right, now this is a printed circuit board, right? So these are again very common. And how do we get components on it? It's through a process called soldering. Now, if we have a little bit longer time, I teach you how to solder because there are some soldering stations down in the makerspace, right? But how it works is that you have, for example, so if we go back to the start of the GIF, we have this line here, which is a component, and then we have this circle here on the printed circuit board, which is another active component, and then we just have to create an electrical connection, right? And the way to do that is through this soldering material, so that soldering material there, which is electrically active, and then you put a heated tip there just to heat it up. It melts that soldering material, and then the soldering material completes the connection between these 2 components here. Does that make sense? So that is how to solder. And obviously soldering can be done manually, or it can be done automatically using robots. Okay, so this is, and again, another common process. So if you take a look at the bottom of your Arduino things, you'll see that all the components have been robotically soldered, right? So very, very cool. All right, now why do we need solder? So sometimes you get what's called pinless components, okay? So we've made sure that every sort of component in this pack is pinned, right? Meaning that there are actually pins that have already been pre-soldered for you, so you don't have to deal with soldering. But sometimes you might see components out in the wild that don't have any pins whatsoever. In that case, you must buy this sort of pin header thing here. and then you have to solder this component to this component here. You literally just put this above like that, and then you solder the components. That's how you sort of electrically connect these components, okay? And you can buy your own soldering kit, right? Like, I don't know if you'd recommend doing it at home, but you know, some people just have one at home. Just be careful that when you're doing soldering, right, you have to have some ventilation because the solder fumes can be toxic, right? And so you can actually just buy a kit yourself, buy a sort of small ventilation thing, and then you're good to go, right? So we did that in the pandemic. All right, so this is a microcontroller, okay? So this is what you'll see on the main part of the Arduino, right? So there's a little microcontroller there. And how it works is that it has a number of pins, okay? And some microcontrollers have this little notch here to indicate what the orientation of the microcontroller, okay? Now these pins all have completely different functionalities, so they're not interchangeable, right? So it's like if you do something on pin 7, sometimes you can't do it on pin 6, okay? So you have to be careful and read the manual. Now, this is an Arduino, okay? So this is the most common Arduino. It's called the Arduino Uno R3, and that's exactly the same one we're using because it's so well supported and it has so many sort of cool things that you can do. So we'll go through sort of each component of the Arduino. So the Arduino is very useful in that it deals with some breadboard connections for you. So it's just a little bit easier for us to use. It does add additional capabilities, right? Which is really cool. And it deals with what's called the hardware abstraction layer. Okay, so historically, mechatronics engineers had to build software for this every single time they wanted to use it. Okay, and if you ever study mechatronics properly, you actually learn how to build all those different layers, right? Because you understand how all the different functions work. But Arduino deals with it automatically for you, which is something that we need right now. And it is very accessible. So it's obviously has made mechatronics a lot easier to do, but it is slower and more expensive. So it's great for prototyping, but usually out in the wild, if you're gonna make a real device, then you have to operate on this thing, not necessarily the Arduino, okay? Now, just a brief sort of talk about abstractions, but how we deal with the hardware abstraction layer is that someone has already built for us the software, okay? And it sort of makes our lives a lot easier, right? And so you're going to be taking a look at this software layer and then also maybe potentially underneath as well, particularly if you're dealing with some of the more complex peripherals. All right, and the Arduino itself is part of a huge series. This image is not very high resolution, but what you have is what's called the Arduino Mega, which is the most powerful Arduino in the series. You have the Arduino Uno, which is sort of the intermediate, and then you have the sort of Nano series here, okay? So these are for particularly very fast, very small footprint, very low voltage requirements. Now, we also have the Arduino Uno R4, which has just come out a few months ago, which allows you to connect to Wi-Fi and also has an onboard LED, but this has seemed a little bit overkill for us, so we stuck with the Uno R3. All right, now some of you might have been discussing textiles, but at some point there is also this sort of cool series called the LilyPad Arduino, which allows you to integrate electronics into textiles. Okay, so if ever you want to do a project with textiles, you can actually use this technique and be able to integrate it into clothes and that sort of thing. All right, so this is what an Arduino looks like. So we're going to look at sort of different components. Now, that's missing here, but let's talk about firstly about power, right? So there are 3 ways to power an Arduino. The first that we're using, which is a standard one, is this USB-B jack port here, right? Which just simply connects to a laptop, and the laptop provides all the power that the Arduino needs. This one here, which is obscured by that, is you can actually connect a 9-volt battery to a barrel jack here, right? So if, for example, you buy a 9-volt battery, there's actually an adapter in the packs that allows you to make something handheld. Okay, so if you don't want to touch your laptop, you can literally just go out and buy a 9-volt battery and connect to this and it'll work. And then if, for example, you want power via another Arduino, it is possible to actually put in power in these ground and power input pins here, right? But we won't be using this functionality at this stage, okay? Because you need multiple Arduinos communicating with each other. All right, now, in terms of software, if you haven't already, maybe for this table here, download the Arduino IDE software, right? And how the software works is that you need to program, again, via this USB port, okay? So it doubles up both as a software and a power sort of port. All right, and then finally, this is another piece you need to be aware of, but there is a reset switch right next to the USB. If you're running your code, you've modified it, and you want to rerun the sort of new code, then you can hit reset. Does that make sense? Or you've done something that takes a while, and you want to start from the start in terms of the software behavior, then you hit reset. All right, Now, how do you actually power your breadboard? Okay, so the breadboard obviously by itself doesn't have any power, it's just merely a board rack, but you can actually power it by connecting the 5-volt and the ground pins to the plus and minus strips of your breadboard, okay? So I want you to do that first up, which is connect these 5 volts and the ground pins to one side of your breadboard. Okay, so we're just going to go around and make sure, yeah, using the male-to-male connectors.
You go higher out.
Especially your hiring and such. Everything you can fashion.
Oh, yeah.
Coffee machine. That's a file. Jackets, you know.
Yeah, absolutely.
Alright, just for debugging purposes, right? So it's a bit easier for us, please make sure to use these pins in particular, right? So the 5V power output pin and the ground pin, okay? Yeah, yeah. And so another good practice to have as well is black is ground and red is 5 volts, okay? So black is ground, red is 5 volts. Always use that color scheme, yeah. Five volts and the ground one underneath 5 volts, right? Red and black. So black is ground and red is 5 volts. Black and red, yeah. Black and red, so we can do one black.
Yeah, that's
What would it put into? Yeah, I know, right? More or less. Yeah. We're gonna have to. No one think this is a big one. No, we have to look at it. No, it doesn't plug in, bro. You have to clear that angle. Sure you got it in. I'll put it in.
This,
Yeah.
okay. You might consider using a lumber as well.
Like, what do you do already? I feel the red one might.
Just slightly, just slightly.
Yes, slightly, it will, yeah. You don't need to shove it in, right? Yeah.
Whoa, whoa.
Unplug your.
First thing we do is short the fucking line.
Yeah.
Yeah, it's totally fine.
No, you will trade it.
Show me five.
Yeah, the ground is.
Yeah,
This is the red one. Blank. Wrong one.
Wrong, the negative one, right? Can one be offline?
Ground's too long.
Yeah.
Why don't we say? Don't worry, if you want to go too. Yes.
Yeah.
So you
Yeah, that's a. Can test them.
Maybe someone finds Yeah. Oh, I get $30 extra. Oh, shit. You go last night? Oh, we were literally thinking growing. We were crying.
Okay, so let's explain a little bit of the logic behind the breadboard, right? So now that I've connected this to 5 volts, right? If I, for example, put it on this row here, right, which is row 30, then row 30 now operates at 5 volts. Does that make sense? Okay, so if I put this here, so I assume it's connected, but if I've connected the Arduino to this, and this is 5 volts, if I connect it to row 30, then row 30 is now 5 volts. Does that make sense? If, for example, I shift this here to 0, then it's now operating at 0 volts. So if I put this one here, and then I put another one on, like this, what should I not do? So if I have this on row 15 and one on row 30, what should I not do to avoid short circuit?
Not to.
Yeah.
Not have a resistor connecting it to the 0.
No, so you don't want a connection between row 15 and row 30 without a resistor.
Yeah.
Does that make sense? Because this is now operating at 5 volts, this is operating at 0 volts. Okay, you don't want to short that connection. Does that make sense? Okay, so that's how the breadboard works. All right, cool. Now that everyone's done that, move on. Okay, now we have a bunch of pins, right? And so outside of this, this is a set of what's called power pins. So it's related to power management, right? These ones here are called analog input pins, okay? So we'll discuss the difference between analog and digital very soon. And these are called the digital pins, okay? So this whole strip here is dealing with digital input and output. So what is the difference between digital and analog? So this up the top here is what's called an analog signal. So historically, we've always used in electricity or electrical engineering, this analog signal, right? Which is a signal that, for example, between 0 and 5 can take any value. Does that make sense? And then for digital, it only is restricted to 0 or 5. Okay? And we have shifted, obviously, in the last sort of 30 or 40 years to only using digital signals, okay? Because we found that they are much, much better than analog. All right, now how does digital logic actually work? So obviously when you deal with this, it is never strictly 0 or 5 because you have noise, right? It is, for example, it could be 0.1 or 4.9, right? There is always noise on a line and it impacts that digital signal. Now how what's called the TTL logic, so transistor logic standard actually works, and this is for 5 volts, is that you have an acceptable input range, right? And then you have an acceptable output range. And so what you'll notice is the output range is always a little bit narrower than the input range, right? And what that means is that if, for example, a device outputs 2.7, the noise could bring it down to 2 volts, right? And that will still be accepted as a high. Does that make sense? So if, for example, you have an Arduino chip that is accepting digital inputs, right? If it sees 2.3 volts, right? Then it will treat it as a high. Does that make sense? So it always returns a high. And if, for example, here, your output is 0.5, due to noise, it goes up to 0.8, right? If Arduino sees 0.8, then it treats it as a low. So it sees it as a 0. Does that make sense? So it actually, in reality, treats this entire range as a high. So if it sees anything from 2 to 5, it is automatically a high. It's seen as if it's 5 volts. And then if it sees anything from 0 to 0.8, then it's treated as a low and it's seen as a 0. Now, if it sees something in between here, so 0.8 to 2, right, which should never happen, but if it does, then it gets confused and it returns neither a high nor a low. Does that make sense? All right, now there are always different standards. So we are talking about what's called the TTL logic standard. So you have to make sure that whatever device or peripheral you're using actually adheres to the standard. But there are other standards. So for example, this is what's called the CMOS logic standard. Again, a sort of similar principle. If it's seen anything from 0 to 0.8, then it's treated as a low. If it's anything from 2 to 3.3, then it's treated as a high. And anything in between that's not sure, right? And so this is the operating standard for 3.3 volt devices. Okay, so some devices operate primarily at 3.3 volts. And the reason why you might want to operate at a lower voltage is you end up using less power. Okay, so peripherals end up using less power. And so the iPhone is famous for trying to push the standard as far down as possible. Okay, so a lot of components on the iPhone, for example, operate at less than 1 volt. Okay, which means that it has very, very minimal power and it lasts a very, very long time, right? Because you can have a battery with a finite power. Now, the analog problem is this. Analog read and write is actually very, very expensive. Okay, so we won't dig into why, but the circuits are extremely complex, right? So how can we replicate analog with a digital signal? Does anyone know or have any ideas on how we can do that? So let's go back. So what I'm trying to say is I want, for example, an average value of 2.5, right? So something in between 5 and 0, right? With a digital signal. So a signal where we are only locked into ones and zeros. Any thoughts on how we can achieve that? Yeah.
Resistors and stuff.
Resistance is one. No, resistance is not quite it. How would you achieve, for example, so I say I want an analog signal that averages at 2.5 volts. Okay. How would I achieve it if I'm only allowed to do 5 and 0?
Yeah, the equal number of 0 and 5.
Yes, exactly. So you have an equal time spent in 0 and equal time spent in 5, and it will average out to 2.5. Okay, so this is a strategy that is very popular and very common everywhere called pulse width modulation, or PWM. Okay, and basically it says that you can get an average value of any value you like between 5 and 0, as long as you what's called duty cycle it for some time. Okay, so it's basically if you turn on 5 volts for 50% of the time and 0 volts for 50% of the time, then it averages out to 2.5 volts. Does that make sense? So a lot of components operate off this logic. So it does not accept an analog voltage, right? But it accepts a PWM value based on the duty cycle. How, for example, would I achieve 1.25 volts? How long do I turn on 5 volts for, and how long do I turn on 0 volts for? Yeah, 25 and 75%, right? So you turn it on for 25% and you turn it off for 75%, and that will get you an average of 1.25 volts. Okay, so that logic applies across the whole spectrum. You can change that percentage however much you'd like, right? So as you can imagine, you can pretty much fine tune this to get any voltage you want, right? But it's just a digital signal that's pretending to be an analog signal. Does that make sense? All right, so here are some examples, right? But you could, for example, have a 0% duty cycle, it's just equal to a 0, 25%, 50%, 75%, 100%, it doesn't much matter, right? You can have any value between 0 and 100%. All right, now Arduino can read and write digital, so it completely deals with digital because the circuits for this are very, very cheap, right? Arduino can read analog, right? So it can actually read like 2.4, 2.5, whatever you have, right? And it can fake write analog. Okay, so Arduino just isn't powerful enough to write real analog, right? And by fake I mean PWM. Okay, so it can PWM analog. And so we'll see an example of that later on. So input pins, again, so these are the digital I/O pins, right? And these ones here are capable of digital I/O as well as analog inputs. Does that make sense? And these ones here, PWM, are ones that can write out pulse width modulation signals. Okay, so these can sort of fake write out analog signals here. So these ones here with a tilde or PWM labeled as PWM. Now, what you might also see when you're looking at documentation for Arduino is what's called a pinout diagram, right? Now, this is what mechatronics engineers actually look at when they're trying to figure out potential capabilities. And so just to sort of orient you to it, right? These ones here, so the yellow ones are what's called registers. So if you're actually touching sort of underneath the software layer of Arduino, you need to refer to what's called registers. Okay, so these are yellow here. These here indicate that these are digital pins, right? The tilde indicates that it's capable of PWM. And then these ones here indicate that it's analog. Okay, so this is a sort of common diagram. If you end up ever sort of doing anything mechatronics, you need to be able to read this what's called a pinout diagram. And there's a color coding, an explanation of what each color means here. Okay. Now you might also see these sketches here as well, and we won't go into it too much, but it is capable to actually CAD out Arduino circuits, right? And you actually practice drawing some of these basic circuits because it's a very effective debugging tool, right? when you're trying to debug an electrical circuit, you need to be on the same page about what the circuit's supposed to be looking like and what you actually see in front of you matches the circuit that you think it is. You will also see stuff like Arduino CAD that you can use. So I don't know if anyone's planning to integrate Arduino into their products, right? But you can actually download these products and then just build off a case or whatever is around it. All right, so moving on to the sort of the next paradigm. So we've installed Arduino IDE. This is the structure of an Arduino program, right? And so you have two components here. The first is setup, and then the second is to loop continuously. Okay, so we'll go through what that paradigm means. So this goes through what's called event-driven programming. And so this is a slide that we have from intro programming, and how programming usually works is it runs linearly, right? So it runs that, and then that, and then that, and then that, and then that, okay? So it always sort of just goes linearly. Now Mechatronics flips that a little bit, okay? So we'll talk about what that means. So we have these two functions here, which is we have loop, and then if something comes in, then we do an action, okay? So if we go back to this sort of structure here, we have setup, and then this program just loops continuously, right? And how it does so is just simply using a while true loop, okay? So sort of behind the scenes, it just goes while true, and then it loops continuously. And the reason why we have that is that the real world operates a little bit like that, right? So say for example, we have this function here, which is loop, and it checks for these events, okay? So it checks for event 1, event 2, event 3, and then based on these events, it takes a certain action. So action 1, action 2, or action 3. So if you think about how the real world works, a device is just sort of waiting there until something happens, right? So if you think about, for example, a microwave literally is just waiting there until someone presses a button, right? And then when someone presses a button, it does something. And then it waits again, right? And then you press another button, and then it does something, right? So that is just how the real world works. So all these devices are the same paradigm, right? Which is it's doing nothing until someone asks it to do something, okay? So for example, you could press a button and then it turns on a light, okay? So this would map out to event 1, which is you press a button, and then action 1 is it turns on the light, okay? And then it waits. And then you press the same button and it turns on that light again, okay? And then it waits. And then you could press a button and it turns on music instead, okay? And then it waits. And then it could, for example, detect the two people a certain distance away from each other, and then it starts playing music. Okay? So that's the sort of event-driven programming, which is it's based entirely on, it's just waiting for events to happen, and then it does something. So this is, again, very big in things like microwaves, right? It's big in medical devices. The iPhone itself uses event-driven programming, right? It waits until I press something on the screen, and then it does something, right? Otherwise, it does literally nothing, and it just waits there. And it also works, for example, in user interfaces. So for example, if you use Chrome, right, then it also just waits for you to do something. You press new tab and then it does, okay? So this is what's called event-driven programming. It's entirely based on events. Now, the Arduino IDE actually calls setup and loop for you, right? So you just need to put code within setup and within loop. Does that make sense? Okay, so you don't need to take care of anything else beyond that. Now we're going to skip this whole section of C++ here. So if there's any questions, then please just reach out and then we're happy to help you with C++. All right, now some important things though is this is how you print an Arduino, okay? So this is actually setting up what's called a serial to terminal, which is to set up a line to the terminal. And then it will, for example, if you put in this code, just keep on printing a certain string, right? Which we define as hello world. So it keeps on looping and printing that many, many times over and over again. All right. Okay, so Arduino functions. Now there are 6 Arduino functions that you need to be aware of, right? And we introduced another one on Thursday, which can be particularly useful. So Arduino itself has a huge documentation, right? And so when you're dealing with mechatronics, people are a little bit old fashioned, right? You have to refer to the manuals, the documentation, the data sheets of different components, right? Because they always explain different things and you need to understand how it works, right? And so for example, if you ask me how a certain peripheral works, I'll just simply have to look at the data sheet because I don't know, right? Like I have no idea what it actually does. And it's the same with Arduino. So Arduino has a giant list of potential functions that you can use, right? And you'll see some of these are common in Python, right? So for those who have done Python programming, you'll see that these are very common for Python math, okay? And then there's all sorts of other stuff that you can do, but we're not going to touch on it. Now, this is what the documentation actually looks like. So it describes, for example, the function, so digital read. It's to do with digital I/O. It reads the value from the specified digital pin, either high or low. And this is the syntax. This is what it actually returns as well. So one of two values, which is either high or low. And these are the parameters that you have to put in, which is what pin you want to read from. Okay, so again, these documentation is very excellent. They will have examples as well of code that actually works. So please do refer to this. Now, the sort of 6 functions that you need to know are the following. So the first is pin mode. So pin mode is a setup function. It is almost always in the setup part of the code, right? So just be aware of that. It's always in setup. And it specifies a pin as either a digital input or digital output. Does that make sense? So you have to specify, for example, that you want pin 13 to be an output and pin 4 to be an input. So it is one of the very first functions that you always have to write. Okay, so just pin mode 4, I want this to be an input, I want this to be an output. Okay. Now there is a third optional thing that you can do, which is pin mode pin input pull up, right? And basically what this means is it's a bit more of an advanced function that we'll see on Thursday, but it avoids the need for an input resistor. And the reason why is that these pins internally have resistors just in case. Okay, just in case it sparks or whatever, some of these pins do have input resistors, but you have to turn it on for it to work. Okay, and so one of the sort of reasons why we don't teach it first up is that it inverts high and low. Okay, so it's a little bit confusing because if you're expecting a low, it then becomes a high and vice versa. Okay, so it is something that you'll see on some peripherals where they expect you to use this. You just have to know that high and low can be inverted. Okay, and it's usually inverted. And we're not going to use it for today, but it's common for peripherals so that they avoid you having to have a resistor, right? Because the resistor is already inbuilt into the Arduino. But we're not going to use it today because I need you to practice putting a resistor on, right? And actually always doing that because not all boards have this capability. Now, that's the first function. The second function is to read from a pin. Okay, so if you know that you have a digital input, then you can use what's called digital read, put in the pin, and then returns either high or low to this variable. Now, you always have to remember that you have to actually store this variable, right? If you simply read it, obviously the value is not going to be stored in anywhere unless you store it into a variable yourself. Okay? So it reads the digital pin value from the pin, it returns either high or low. And like I said, this uses an enumeration whereby high equals 1 and low equals 0, right? And it's always an integer. So when you're initializing this variable, it should be an integer. All right. The third function is what's called analog read. Okay, so analog read reads an analog value from a pin, and recall that the pins that are only analog are the ones on the left, right? So A0 to A1. So these are special pins where there's an A in front of them. Okay, so the digital pins are all numbered from 0 to 14, but the analog ones are A0 to A5. Does that make sense? So it returns an integer from 0 to 1023. Does anyone know why this value in particular is present? No? Any ideas? Okay, so the reason why, and we'll discuss through the slides, is that this is what's called an 8-bit resolution analog to digital converter, right? Meaning that it only operates with a resolution of 8 bits. Okay, and 2 to the power of 8 is 1024, right? And C++ is a zero index language, and so it starts from 0 to 1023. Does that make sense? So it will always return a value there whereby 0 corresponds to 0 volts and 1023 corresponds to 5 volts. Okay, and if you take this range and you divide by this amount, this means that you get a 4.9 millivolt resolution. Okay, and recall that it must be from an analog input pin. If you try an analog read from a digital pin, the function is going to break. Okay, now why 0 to 2? So not 8-bit, but 10-bit. Is to 1024. Now you might also see 8-bit, 12-bit, and 16-bit. ADCs around, which means that you have 0 to 255, 12 bits are 4,000, and 16-bit is 65,000, okay? Meaning that this is the resolution you get depending on what you buy. Now, obviously, this is a lot more expensive, right? Because you're getting a very, very high resolution, right? At the level of microvolts when you're dealing with the analog to digital converter. All right, the next function to be aware of is digital write. So this just basically says, I want to write to this digital pin either low or high, okay? So sometimes with certain peripherals, you need to write that this is high or this is low. The next function is analog write. So recall that when we're writing analog, we're using PWM because we don't have a real analog write function in, right? So we're using pulse width modulation, and so we need to write the pin followed by the duty cycle that we want. Okay, so you need to refer to whether you want 50% or 60% or 70% of that value between 0 to 5. Now the duty cycle value itself is actually written from 0 to 255. And again, it's because of an 8-bit sort of nature, whereby you need to refer to this value. So 0 here maps to 0% PWM, and 255 maps to 100% PWM. And recall that you must use a PWM pin, okay? So to recall which one's a PWM, there's that tilde sign that you can actually see on the Arduino, and make sure that you use a PWM pin. All right, the final function is delay. Now, delay is a function that basically just says you run a piece of code and then we wait for a certain number of milliseconds. Okay, so delay 1,000 means that you ask the program to wait for 1,000 milliseconds, okay, which is 1 second. Now, this is actually not really considered good practice, but we will allow it for today because you haven't learned sort of other ways to get around it, but you will rarely see this in real mechatronics practice, right? And if you start writing code with delay, it's sort of almost like a fireable offense sort of thing. So please don't use this outside of this class, okay? All right, so this is it. These are all the functions. So we'll have this as a reference on each slide so that you can remember what functions you can use, okay? All right, so we're going to go through the exercises now. So when you're working through exercises, there are 4 sort of things that you need to have down before you start building your circuit and start writing your code, okay? And we're going to be sort of strict on this because these 4 things are really critical for you to get it right. The first is you need to figure out what components you need and how they actually work, okay? So you need to understand how the components work, potentially read up on the component if you've never seen it before, read up their data sheets and make sure that it actually matches the Arduino voltage, right? So you need to make sure that. The second is you need to figure out which pins on the Arduino you're going to use, okay? And you have to have a good rationale for it. If you, for example, need an analog input, then you have to make sure that you use an analog input, right? If you need a digital I/O, then you make sure that you use a digital pin. If you need a PWM output, then you need to specify which exact pin you're going to use. The third is you need to draw out your circuit, okay? So one of the hardest things when it comes to hardware is that you no longer have sort of a debugging engine that tells you exactly what the error is, right? You need to sort of confirm with your team that you have the right circuit and that your components are actually correct, okay? So a lot of errors come from the fact that your circuit is different to what you've actually put into place. Okay, so you need to sort of have that down. And then the 4th component is pseudocode. So you need to write in comments. So you use comments, you write in comments in C with two forward slashes, right? That's how you write comments. And you need to have what you're actually going to do in code down. Okay, so mechatronics code is usually a lot simpler than the sort of complex programs you get with Python, but it's very easy to screw it up because you don't know what you're doing, right? So write out the pseudocode and figure out all these 4 components before building your circuit and coding up your program. All right, so our first task is to turn on an LED, okay? So let's go through what that actually looks like for these 4 things here, the components, the pins, the circuit, and the pseudocode. So the components that we need are the following, right? So we're going to run you through this just the first time, so you get used to it. The first is you need an Arduino board that is connected to either a laptop or a battery. In this case, we're just going to connect it to a laptop, okay? So this is going to provide the 5 volts that we need. The second component we need is an LED. So you can choose an LED of your liking there. So take a look, whatever color you'd like. What you'll notice in your LED packs is there's no blue LED, and it's sort of a bit of trivia, but blue LEDs are very expensive to make. And it's a lot more expensive to get a natural blue color. And I think someone won a Nobel Prize because they managed to get a blue LED, right? So it's actually really difficult, right? Yeah. But you won't see it because it's too expensive. Now, how LEDs work is that there is a polarity, okay? So I've been caught out before in one of my past projects where I screwed up the polarity of a different component, right? And so you have to make sure that you get your polarity right. This here is considered the anode or the positive terminal. This is the negative terminal, so you can see by the length there. There's also another mark there, which is that the flat edge is on the cathode side. Okay, does that make sense? So please make sure that you get this polarity right. And this is the anode and this is the cathode. So when you look at the diagram later, just make sure you know which side is which. Okay, because if you put it in wrong, it's not going to work. So see if you can find the polarity of the anode and the cathode. All right, and then the final component is a resistor. So like I said before, you must have a resistor between 5 volts and ground, right? And so how resistors work is that there is a coloring scheme here, right? Where it tells you what the first digit is, what the second digit is, and then what the multiplier is, okay? And there's sometimes an optional fourth band, which tells you the tolerance of the resistor, okay? So we'll be using generally the 5% or the 10% tolerances. So in your marks, in your pack, sorry, it is actually marked with whether it's 10K, 1K, or 330 ohms. But practice looking and seeing if you can find the 330 based on the color alone, because this is what you actually have to do in real life. Yeah, so see if you can find 330 ohms in particular. Yeah, there's all voltage, right? You get 0.7 volts. Yeah, and the rest is
Well, we want 330, right? So look for an orange, zero. Just orange. And then times 10 to the power.
Orange, brown,
So orange, brown, and then what's orange one? 5%. Orange,
every single one.
Usually.
Oh, yeah, I've got the orange.
There's only 3 different kinds here.
So remember to put in a resistance, right? Resistor, we'll talk about this later. But if you just have an LED, it will break, right? Because it's going to snap, and we'll talk about why. All right, so make sure you have all these 3 components, right? So a resistor that is 330 ohms, so make sure that it's 330, an LED, and an Arduino. We found 330?
Yep.
This is.
Wait, it's just red.
Yeah.
It is.
Oh, no.
Okay, that's orange.
Alright, then I have to
Maybe that's it. You'll be able to see the what do they call it?
Yes.
Anyway, so I want to take out.
Oh, okay.
Orange. If you found the 330, and practice with the 1K and the 10K ohms as well, right? See if you can find and figure out which is 1K and 10K without looking at the market.
Okay, 1K would be 1, 0, 10.
So you get the first 2 digits and you find multiply.
It would be brown, black, red.
Brown, black,
Oh wait,
Orange, browns.
Yeah, brown, black, oh, this is orange. Yeah, brown, black.
Yes.
Oh, it has 10% on it.
Yeah, so just keep in mind resistors are made imperfectly, right? And so there's always a tolerance, right? It's never just perfectly 330. It can be 5% higher, 5% lower, 10% higher, 10% lower, depending on what's printed on the resistor. Right, as you can imagine, the lower tolerance you get, the more expensive the resistor gets, right? It's almost near perfect.
Harry, like, we don't have to actually make it.
Okay, so moving on. So which pins would you like to use for this? What pins are possible? What are we trying to do? We're trying to turn on an LED. What does that mean? Is it digital or analog, input or output? So I always think input or output first, and then do we need analog or digital?
Yeah, digital output.
Digital output, yes, correct. So it's a digital output, right? Which means that which pins can we use? The left side or right side? Right side. Good. Okay, so these are digital input and output pins, right? Okay. So which pin shall we choose? Let's just all choose a certain pin, which is pin 13, okay, just for easy debugging purposes, right? So let's move on. So now we've figured out the components, the pins, right? The next is the circuit. Does anyone have any ideas what this circuit should look like? Yeah.
We've got the two parts of the battery or power source.
Yeah, okay, so 5 volt, yep, 5 volts.
Going out from the 5-volt part,
Yeah.
go down. Then you have the
What's the first component?
the LED,
Yep, LED,
and then resistor,
Yeah.
and then back
And
to
then back to the
0
volts.
volts.
Okay, so we'll
Or
just
5 volts, okay.
make that a bit more concrete, right? It doesn't actually matter which order the LED or resistor is. So in this case, we'll just do resistor first and then LED. But this is an actual Arduino here. It is pin 13, right? Firstly connected to the resistor and then to the LED and then back to ground of the Arduino, right? And so what does that actually look like before you start? So recall that our breadboard looks like this, okay? So please think about the breadboard before you do that. And this is what it looks like, right? You use the male and female connectors in order to create the circuit in your breadboard, okay? It doesn't have to look exactly like this, but see if you can recreate the circuit here using your breadboard, okay? So we'll go around and don't connect your Arduinos first, right? Let us see the circuit first and then you can connect your Arduinos later.
All right, it's just like, just next one. Okay, so what row are we doing?
Yeah.
So for the.
Really asking you questions. Is that gonna make or break it? Please choose wisely.
And so if, for example, this one, so there's a. This is the 5 volt. About 5 volt to the plus. And then, so if this column here
Stays in one row.
all be 5 volts.
I thought.
Okay, so so here the whole thing.
You end up, the 5 here, in the 0,
We're not using that makes it active.
these rows go up like that.
Okay, yeah. Never mind, I'm wrong.
So 5 volts.
It's like
Yeah.
Yes, and then we put 1 and
So these
So
five.
once you put this over in here, so
And then the next one is
over the
6.
5 volts.
Okay,
And then 0 volts.
and you're gonna ground it.
Connect this.
Yes. Oh, sorry, that's
all right, okay.
That's what I was.
So how do we do it?
I don't know if that's.
So you know this is
Start at
5
13,
volt,
right?
So why
Start at
is it
13.
Start using this.
I think you can go
We start at
grounded together.
Like another row.
Yeah, you're right.
Then the.
It won't matter, it won't matter.
Like one row to the whole thing.
Yeah.
To the one. So that's same row.
Yeah.
Another.
So,
And then
so we're not.
another LED, the negative part of it, but it's connected to another row that is
It's actually control it. So it's ground.
Okay, so you want to go to five?
And
I've
it's all hard.
never seen this in gravel, which is not really right. And this one was fine.
Okay.
So this is.
Okay.
Okay, then we want to do this first.
You can directly.
Please resist it first.
Right, 1, 2,
Now just recall that there is no connection to the 5 volt there,
Yeah.
right? So just make sure that there is actually no connection from 5 volts from your Arduino, yeah?
Let's not look at anyone else. Alright, so so no analog, right?
This one should be connected to the 5 volt.
Yeah. If you simply connect the 5 volts, just say on the way, right? We want the ability to turn it on.
So you need to basically put the so wire.
The 13 is
Alright, and
directly
then
connected.
connect back to zero.
Well, 13 is not connected.
Yeah, we need to connect the 13. Also, we.
And then back to
So wires.
keep
Or like, go directly. Yeah, that would.
Alright.
Alright, let's take a look, so. Yeah, we go to.
Oh.
Take a shot.
So-
This one, and then you have system, yeah, short side as well. And then you have this one here, so you just stick it into here, so what would be wrong with this image here? So, say for example, this is ground,
Yeah,
that whole row there would come ground, right?
yeah, so put the
Yeah, you want the, so you never want the LED together.
To be.
I don't cap it should always be in separate rows.
Okay, okay. Run this whole row.
How would you fix that?
Now.
Press start, yeah.
Yeah.
Yeah, it's like, yeah. Okay, so, yeah, so this one here, it's always good practice to actually put this, you never put anything. So we have one round, for example. So, yeah. So, yeah, so if you put this here, what would happen? What would be the voltage? Sorry?
Yeah.
Yeah, sort of a short bit, also means that like the voltage at the end.
Yeah,
It's not, it's not clear.
There, there. So make it face forward.
Yeah.
So, it's just these 13.
Oh,
Yeah, so this one here is Japanese.
No, so right now. So when you write the code, we check it all. But you can put it on one.
Wait, so anode is this one? Oh, okay.
No, it's just like.
Okay, yeah.
That's something. Yeah.
Okay, what's not up there?
That should be fine. Yeah, the whole row would be fine. So every single one of these holes. If I was every single one of these holes here, it's 3 volts, right? Yeah.
Yeah, but add a certain.
Yeah, later. Yeah. Think about it later. Okay, think about how you did
You just click here, so this will be immediately, then positive, so you can like.
Yeah.
Like 12, and then with this, like,
So-
okay.
Right?
Yeah, right now we still have-
Okay, so I guess.
Also, so this one, the 31 can be.
Because you're gonna say.
Yeah. Again.
Yeah, correct.
Yeah, so you.
Yeah.
This is flashing.
1 second, we need. Yeah. Yeah.
I don't know why.
It's okay. Yeah, good job.
Great. Oh, I see what they've done. But do you need to go there? You didn't tell us that we had extra bubbles.
Thing to like maybe
In the firewall.
It's your song.
Yeah, I think it's
Soon enough we'll talk about it. So either higher
You ever thought of?
Yeah, what's up?
Oh, so if it's high, it's always.
Oh, wait,
Oh, that's the
is
turn
this
off.
wrong?
And also for this one, so it's like this small, I say this small will not be the same as this.
Yeah.
Yes.
Just make that note.
You know, I I'm pretty sure it's six.
Can we turn it off? Is it meant to be working?
Is it already working?
It's because it's matching the
LED light.
So just a quick note here, so these lines here are not connected to these lines here, right? So there's sort of a valley in between there and it disconnects these two, right?
Yeah.
You guys want to
Check.
connect to
Yeah.
I don't know. Yeah, what is it?
It's fine, I think it's how it's supposed to be.
Plugged it in.
Yeah.
Oh,
So this is back to ground. So again, best practice to put this on ground, for example, then make a another connection between this going up the line.
Yeah, alright.
That's pretty much done. If you make that connection, then it'll be good, yeah. It's just good practice. It's because it's very confusing if you connect it straight back into the Arduino. Yeah. For particularly for the complex stuff. Yeah. Can you try a?
Okay. Let's plug it in.
Try 12.
What is it?
Oh, yeah. No, yeah, okay, yeah, put it at 12.
Well,
Thinking of your, okay, this is pink. Okay.
Oh, they're not.
oh,
Yeah, but it's like more than a second delay. One Mississippi, two Mississippi, one Mississippi, two Mississippi, one Mississippi, yeah.
Technology does.
I'm glad we've got that to more than one second.
12 does the same stuff. Okay, could be like an on setup thing, you haven't done any code, like it just does that, right? Like it's fine, and I think everyone's thinking of the same thing. Cool, okay, let's move on. Okay, so now let's think about the code, right? So we want to turn this on in code instead. So one of the key differences is that if you connect this straight to 5 volts, it's always going to be on, right? But the reason why we're connecting it to a digital pin is it allows us to control when it's on and when it's off, okay? So what would the pseudocode look like here? So I've got the 6 functions here that you need to use, right? What sort of things do we need in the setup and the loop? Yeah.
With my hand up.
Sorry, yeah.
First one, pin mode,
13.
13 output.
Yep. So pin mode, so that's just setting up the pin, right? So we need to set up pin 13 as an output. And then what else for the loop? So there's only 2 lines of code. You've got one. What's the second one?
Digital right?
Digital write. Yeah, digital write what?
Make it high.
13 high. Okay, so let's talk about here. So set pin 13 as input and set pin 13 as high. So that's the pseudocode, right? And so see if you can write the code for that.
For the input. The pin 13 is high.
Oh, wait, it's all caps.
The pin.
Oh, sorry, it should be outputs. I'm sorry, my bad. Sorry. Yeah, see, this is wrong pseudocode here. This should be outputs and then high. So I'll fix that now. Yeah. Output and then high.
Usually uses sensor.
Input is, yeah, a sensor and you're getting information into the, yeah.
Yeah, because it's like sensor.
Yeah. Yeah.
So you want us to do that on the satisfied?
Now that I have the code in.
Yeah. Okay, now we have it.
Verify, upload.
I don't know.
We press the,
Yeah.
ah, wait.
It's your fault.
This thing. I think so. Reset one.
Why is this flickering? Press upload, press tick and then upload.
Verify. Oh, missing XUVA.
Oh, you need to select.
Yeah, yeah.
There we go. So before you run your code, you should select board, which is the Arduino Uno R3. Select board.
Circuit tracker.
Yeah, select board.
Yeah, compilation error.
Arduino.
Yeah, so there is an error. So what's the error?
Ah, there's a.
You're missing something.
I think in the,
Wait.
yeah, this is the same thing that said always happens.
Arduino Uno R3.
When is going to tell the cell to run the commands?
You need to select.
So it goes to anode. Well, actually.
Yeah, but I always wanted to.
Arduino Uno.
Anode is positive.
No.
Press verify and see if it works.
Anode is positive.
Cat, well, cats are.
Okay.
Now.
See, it's like, there's stuff happening there, but then it ended up, I remember it.
I remember.
In chemistry, it was negative, but because it had positive stuff. It's been years, I'm fine.
Is it still not working?
Yeah, it's like whenever I verify, like, see,
No, it's
verify,
not.
Especially updated to the Arduino Uno, and then it should be.
and then the upload should be fails.
Yeah.
And open by access to deny.
I can't even find it. Press, verify.
No, it's just Uno.
Just.
The guy?
Yeah.
It's got a mind of its own. Should ask for consent.
Oh, there you go. Okay. You had this in your codes. You know, the syntax matters. You have to
This is not.
leave no space like.
Okay.
Absolutely.
There you go.
Alright.
So, yeah, you can do, what else?
can do one, but don't worry.
Well, actually, you can do.
They didn't even want
You
you.
didn't want me.
Oh, now it's.
Cool. Right, any issues?
Oh, yeah.
Oh, yeah.
So maybe run the code first. So how do you set the pin 13 out?
Oh,
Which of
it's,
these functions?
Alright, so what's
in mode?
Yep, pin mode, 13, output.
Oh, yeah.
So,
Oh, yeah.
run the code, yeah.
Oh, my days.
No, but not relative. What's the loop?
Yeah, yeah.
What's gonna happen?
Yeah.
Pin mode, 13.
In mode,
So it goes,
comma 12.
so it's looping, right?
Yeah.
So it's gonna go high, and
Then it's gonna do nothing with it.
yeah, that's fine. And
And
then.
then it's gonna turn it off. And it's
The
gonna
12 comment
turn it
output.
on immediately after.
Yeah, so you want to add it today,
Yeah.
if you want to see it, or you want to choose. You want to
Output in caps.
That gives it what, a 1 second.
Oh, wait, we need
semicolon. Yeah.
And then semicolon, semicolon, right?
Make sure we get it right.
Pin this one down, so how would you set the pin 12 to high? Did you write? Did you write 12? Caps.
I need to reset it.
Yeah.
Yeah, you don't need to reset it, it should reset. You can play around with the numbers,
Semicolon.
try to delay it less, try to
Click
delay it
verify,
faster.
tick there. And then.
You see what you choose here.
So we had that really good.
And then-
Great, there we are, yeah. Yeah.
So we just did nothing.
Why is it when?
That's the important shit to write down.
It would all be the, well, it's all easy. So. We might actually have to expand out, like, the space wide.
So they should have a.
This one.
Yeah.
Put the pin one there.
Sometimes security issue as well.
Wait, can you pause it?
Actually, just try the two ports I have.
Sorry, I just wanted to make it black.
You moved on.
Yeah, try your one. Sometimes it's just.
Just like copy it off.
I thought you were
I
like start
was
running.
It's like this whole stuff. Just plug it out, but.
Oh, yeah, let's click on the ports. This.
No, because it just resets.
Just like this mobile.
But what if you code it to pause?
In series, you do it like.
No, no,
Wait.
Tell it to
Those are the
shoot.
IDs.
And I'll
It's
just
like
have to.
it's flashing, no.
so just take it out of this bit.
The
So
Oh, yeah, but it's
I'll
not
reset
now.
the IDs, sometimes we'll detect it. Connected and reset like close the app.
I guess. Like,
Oh, and then we-
so actually.
Wait, why don't we do the,
There we go.
and we'll,
Connected and then start your Arduino IDs.
on the beach?
Yeah, so.
We like.
Is yours good?
Yeah. We even added.
Okay, cool. So what's the max LEDs you use?
I'm pretty sure.
You know, when we really.
Oh, wait.
There's gonna be a max number. Like an infinite number of LEDs.
Yeah, so that was like more.
Okay, so you need to figure out the forward voltage of the LED, and I don't know exactly for this one, but I believe usually it's 0.7, right? So up to a certain point, you stack above 5. and
Yeah.
then
So 7. So 7.
Okay, so try 2. I think you will stop working by around 3.
Oh. Long as like, if you go to an average, it would be like, it'd be like.
One pit is gonna be an individual center, it's gonna be a high or low. And then there's gonna be another, actually it might be more than high or low, it might want it to be as great. And it always used to be an access for
What?
Yeah.
Are those that happen at the same time? I don't know how to do that. You need to put another resistor here.
Okay. I finally functional model, so now I have to.
What do you use
figure
connect?
that out. Yeah. I might, it's just like one piece of it.
There's like a kid in the middle that actually.
Yeah, we're not like-
Yeah, I was thinking about the agreement like that. Make it parallel about it series otherwise.
Yeah.
Like they will flash.
The policy. Always. When we took out the red line.
Yeah.
Okay, so we wanna do it like we did before?
Yeah, man, you know what?
The thing is like.
Yeah. And another sanity check is just check another group's function item, right, in case it's not audience, but I highly doubt it, but like, just. Like, like the other machine that we got, right, like it's. Algorithm.
Eventually. So.
So they will just show up.
Show up and, I mean, there's always a team.
And then we'll see what happens. And then we'll figure out how to.
Sometimes it's just.
Take out.
One of your main
Green, yellow.
I was just trying to last time.
Yeah.
Maybe come on, just restart.
And yeah, see if you restart, maybe it's like you install the Arduino and then it didn't register the code properly or something.
That might be.
Sometimes it's what Mac software.
Yeah.
So you're setting it on Mac.
Yeah, like that's good.
Because
It's all
it's
like
not
this.
sometimes leads to a shoot.
Oh, I'll.
Yeah. Well, well, we can parallel and we can follow.
Series.
Is it that?
Yeah. Usually we left branch.
Yeah. How do you start this?
So we do this series. You do, so you guys can go like.
Always.
Go down one.
Yeah.
Now the red, yeah, go ahead.
I think so. Yeah.
Wait.
Oh, again. Oh.
You're right. No, no, no. You bring it. Oh, you.
No, right.
Feel, yeah. Now the other.
Me, the first one.
So, yeah, yeah. Wouldn't be the same amount of the yeah. Definitely.
Nice.
It looks the same.
Hi.
We put a resistance in it too, that was good. So we could like.
They're all 13.
Yeah, just undo.
The switch.
Oh, like uncommented.
Might have to restart.
Yeah.
So it's not really. So it's a red switch, is the only one we have.
No, we have more.
Oh, we did.
This one.
Very good, very good.
Yeah.
Sometimes it's database, there's issues, right?
Verify.
There's all sorts of stuff.
Was it perfect?
Oh, yeah.
All right.
Yeah.
Yeah.
I'll put
Just
it
give me
back.
that one first.
Right, so one of them things. This space.
So I guess and then verify. Oh, yeah.
Welcome to the world. Oh, wow. It's a- Oh, it's
Global maybe.
Oh,
Yeah, Very nice.
Yeah, so that was when we found the,
That's good.
bubble bar.
Let's try and make it. Let's try and make it.
Accidentally, it's
We put it together.
not made.
Excellent, excellent.
Hey, thank you.
Oh, you took.
Oh, wait. That.
I don't know why. I don't know what power you need. I don't have.
You didn't power. Yeah, that's fine.
Yeah, but we don't have the battery.
No, but he did it. You want the future.
I don't know.
Don't like.
Back it in the way.
Oh, you're talking like a.
Let's try that.
Can we see what happened?
Yeah. Alright. Well, no, I'm thinking.
Like, is this the problem?
There's no code in it, so it's not gonna work with it.
Yeah, that's right.
Oh.
You want?
Is that problem with experts? Keep up top with the last section.
Yours also cannot.
This exercise anyway.
Yours also cannot.
You're not using MacBook already.
So what's the problem right now? Is that even computer, right? I'm trying to subway like.
Right, so just the next challenge before we break for lunch, right? And as we're trying to fix this thing cannot connect, right? Which is, what if we now wanted to blink, right? So see if you can make it blink with a frequency of 0.5 hertz, right? Does everyone know how hertz works? Okay, so number of times per second. Okay, number of times per second. So 0.5 is 1 every 2 seconds.
One
Okay?
every 2 seconds.
Yeah. So see if you can make an LED blink, which you seem to have already done.
Wait. Once every 2 seconds. Oh, you want to try and yours? That would.
And then if you want a challenge, then create 2 LEDs that are blinking separately, right? Like on, off, like that, yeah.
And then we have a traffic light.
There's turn on.
Watch, yeah.
Sorry?
That would just all turn on at once.
Yeah, yeah.
Already.
You can look at the diving data sheet if you want to figure it out, but like, we don't see it.
No.
Turn them on.
No, I know. It's level 1.
Here, right? It's actually one in here.
Floating too.
Mac has been eating issues. I expected.
Yeah.
There's not a Mac you can do anymore.
Don't bring similar errors.
No, the issue is that this code literally more.
Yeah, solution is just to.
Oh.
Try that, yeah.
It hasn't even started registering.
That's what I mean, but what happened? I said we didn't touch the card. Yeah.
Yeah, I'm getting the same problem.
Maybe upload it and even after the error shows up.
Okay, yeah.
Like, I can do almost.
My last is not fucking going.
Hey, we want to be a party.
Yeah,
Still
what's happening?
saying.
You're gonna go to time.
Uploading.
You're doing a thousand.
It's one. Oh, like, you know, that's what I did.
No, you need to treat others.
Yeah, so good.
Oh, let's end more switches. Okay, sure. I would recommend just one laptop if you can get it working, like just keep it connected to that laptop, because I think it's a good medium just like changing laptops. You, like,
But we changed once.
No.
And it still works, like, of course not.
The code works?
We got into the software system. Oh, it saves last, it saves most. Yeah.
I mean, some of the access is denied, which is a security thing. I thought that was-
Yeah, but.
Can't find, can you try yours?
Long ones.
Yeah, okay. So we go back to, just do the original one.
Just see if you can do the original one.
No, right there, and then so you want
Well, I
more?
mean, it was verified before.
Yeah. Access is denied.
Yeah, I mean.
Okay.
We should pick a lot, we know.
You don't need it.
Ah, yeah. Always a big. Ah,
No, I mean, it doesn't affect. Yeah. So, yeah, maybe it's a lot of confusion.
Yeah, okay. What the hell?
And then we do it for the problem one.
The search Arduino access is denied. There you have it.
Give me your breadboard and your.
You want to
You want? Wait. Alright. I'll pick top it up.
Yeah, just double check your wire. Sometimes it's a circuit fit as well, like access is denied because it's just something on the switch.
Yeah, it goes back in where you had it.
Well, probably that's what it's no, it's not hard. It's too rough.
Yeah, I mean,
That's hard.
yeah, it's fine.
Put some art, you're not trying to force. Right. Oh. This is awkward.
Cause I was gonna try and borrow your.
He did something, we just the wrong.
Oh, it's your-
Right, I
Yeah.
couldn't read it, and we fixed that. And we sent it out, so to see like,
Yeah.
and then we keep our own comments, and now it's just doing the same problem.
We can find it.
I know something working out.
Yeah.
They're like. Really bad. Are you doing something? What? Oh, like, there's. Oh, we got. What version?
Okay. The way you do it, free, right?
Yeah.
I mean, it works up.
Following before.
You guys can use my laptop if you want. Right, stuff.
Oh, wait, and just see if you can, okay, search access.
This cable works.
Yeah, I think the cable is sometimes
Because I use this, there was ask for like,
Right.
if I use a mouse one, so which means that cables are.
Okay.
No, I just use your cable.
On the.
Yeah, so
It's set up.
Yeah.
And I just try it on. I insert you. Other people. We have couple of them.
Let me see the code.
Yeah.
You know, start device manager. So, yeah.
Okay, wait, exit, another strategy is exit out.
Oh,
Yeah,
wait.
yeah, click on it. Yeah, sometimes.
Should I save it or
Save it,
not?
yeah, save it so you don't have to do that.
Yeah.
Hey guys, another thing to try there, we're seeing on the forums, yeah.
We switch cables with all that.
Now you get it.
Oh, okay, that's okay.
But it says access not.
Okay, yeah, close this and then rerun it.
Maybe a Windows thing.
Could be a Windows
Yeah, I think
thing.
it's a Windows thing for administrator. No, that makes sense.
Yeah, makes sense, right?
Really basic thing.
Well, what do you? Yeah. That's right. It's good, right here.
Like board, like, you know, verify.
Although maybe you guys need my expertise on anything, I'll just be editing my previous.
What are you writing?
What, yeah, but I've worked it, so. hence- That's our time to do it.
Yeah, that would be.
Did you manage to solve the accesses tonight?
You know, try it. I ran as an administrator, I'm still here.
You can.
Yeah, you can use the
It's like
Try yours.
rotating things. That took proposal, but now.
I think I have statements. No,
Yeah,
yeah,
you run
done
it.
it.
Administrator.
What about trees? What about trees?
Presentation.
Oh.
Yeah.
No, no, too nice.
This sort of looks like when it's done, but.
Oh, wait. Maybe,
Yeah.
oh, good.
Oh, yes, they have my question, but yes, but I don't think. Yeah, that was it, and then that has a.
Where would it be?
Oh, yeah.
What? What's the new bill on
Go up and down, and then it's like.
I'll leave you know. Where that go?
What is the one?
Yeah, that goes up and down as well.
The rocket.
Yeah, yeah, but I'm gonna reprint those two pieces and hopefully.
Remember the vice manager and ports? Vice manager and ports? Show me that.
Where do you want me to go?
Yeah, it's a really.
No, so that.
I'll have them.
Ports.
He's not be able to.
Oh, you did have.
Yeah, they're already installed. Because it's saying it's working from PJ can please say, oh, yeah. How do you print it?
Oh,
We're on the same.
Ports conference.
It's just too great, and it says it works properly, there are no updates in the driver. Yeah.
Very, very, It's done, my work is done. Okay, that's all I'm going to. The whole new Mechatronics.
Right.
I think by.
Oh, sorry.
No, I mean, it'll be on, it'll be on, it's too, it will be.
Okay, whatever.
Yeah.
Like sirens with.
So you know the sounds.
Yes, yeah.
On the 50, like.
Cool, there you go. Okay.
Yeah, I know. It was like.
Try something.
We can go to stop for lunch here, right? And so let's come back at, we're gonna need a bit of a faster lunch, so let's come back at 1:50. And yeah, just let's come back at 1:50, right? So just go and get food and then come back and then we'll finish the rest of the exercises. And in the meantime, if you want to go down and check on your 3D print, you can as well and work on any hypotheses.
So you're going to just stop it, just.
You can, oh, press reset. Oh, just reset, rerun the code, just press reset. Okay, so we're on the code, so if you want to.
That's it. So this
Alright, back at 1:50, sorry?
Yeah. Disconnect.
What is it now?
It still has memory.
Ooh.
Check on the bank.
This is what we're going to check.
It looks like it's supposed to be on. Like you know how you record some of your. You want to use your laptop to do the printing? Because mine is.
We bring the server mode down to see if it fits with.
Yeah.
Yeah, absolutely.
So ready to go back to
I think more.
Okay, but what are you doing?
Hey, Frank, can you unplug my laptop?
Oh, okay.
Just have a look whether that.
Brian, do your.
I mean,
Mine also not that.
I'm playing fairly.